Welcome back to the deep dive. We're here to take that huge pile of research and distill it down, give you the essential structure you need to really get a handle on complex topics.
And today we're tackling one that definitely feels complex. It's the system design interview.
Yeah, it's a big one. It has this reputation for being, well, pretty intimidating.
Oh, absolutely. It is genuinely intimidating, right? You walk into the room, the interviewer seems friendly enough,
Sure.
and then they just drop this massive multi-million user problem right on you, something huge and kind of vague.
Like design a global news feed, or how would you build the core mechanism of Google Maps?
Exactly. And your first thought is just panic.
Right, because these real-world systems took enormous teams, years and years to build.
So how on earth are you supposed to deliver some kind of mature, scalable architecture in, 45 minutes? An hour?
It feels impossible.
That anxiety. Totally understandable. But here's the key thing, the core insight that changes everything. No one actually expects a perfect finished product.
Okay, that's good to hear.
Yeah. The real mission of this deep dive is to unpack what interviewers are actually looking for and, really importantly, give you a simple, effective 4-step framework. Something to help you manage this, high-pressure, often ambiguous process.
A framework sounds good.
Yeah.
So if it's not about the perfect design,
Yeah.
what is it about?
It boils down to this. The final diagram you draw, it's genuinely less important than the work you show, the rationale you demonstrate during the design process itself.
So it's about demonstrating your thinking, your engineering maturity, not just delivering a blueprint.
Precisely. It's about showing how you approach the problem.
Okay, so if the interview isn't purely a technical test, what are interviewers really trying to figure out about you? What are these signals they're looking for?
Well, you've got to remember the whole thing is really a simulation.
A simulation, not construction.
Exactly. It simulates real-life work. Imagine two colleagues, hashing out an ambiguous, open-ended problem together on a whiteboard.
So there isn't one single right answer they're checking against.
Not at all. Which means the interviewer's main goal shifts. It's not about checking for correctness. It's about collecting strong, relevant signals about you as a potential coworker.
And they really can't afford for the outcome to be inconclusive, right? They need clear signals.
Definitely. They need to make a hire no hire decision with confidence.
And it's fascinating, isn't it, how many of those signals aren't even about the tech stack details, like whether you pick SQL or NoSQL.
Oh, absolutely. A huge part of it is assessing those let's call them soft skills that really underpin good engineering, maybe even leadership.
Like what specifically?
Well, fundamentally, how effectively do you collaborate? Can you actually work with the interviewer? How do you handle pressure when things get complex or unclear?
Okay.
Can you resolve ambiguity constructively, or do you just freeze up? And this one's critical, maybe the most critical, can you ask good questions?
Asking good questions.
Yeah, many interviewers specifically look for this. If you just jump straight into drawing boxes without asking at least, say, 3 foundational questions about the requirements, that's already a negative signal.
Wow. Okay. So it shifts the whole thing. You're not supposed to be just a walking encyclopedia of tech facts.
No.
You need to be a structured investigator.
Yeah.
Showing your judgment, not just recalling information.
Exactly. Your judgment, your problem-solving approach.
Right.
And on the flip side, interviewers are also actively scanning for major red flags.
Red flags.
Yeah.
Okay. What kind of problematic tendencies are they looking for? Things that suggest you might be, difficult or costly down the line.
Yeah, things that signal trouble. The big one, often called a disease among some engineers in the source material, is over-engineering.
Over-engineering. We hear that term a lot. What does it actually look like in an interview? And why is it such a huge red flag?
Okay, so over-engineering. It's basically when someone prioritizes, theoretical design purity or maybe just unnecessary complexity over the practical trade-offs you always have to make in the real world.
Right.
It's when an engineer designs this incredibly complex, maybe academically beautiful solution, when a much simpler, proven component would have worked perfectly fine, they get excited by the complexity itself.
And they ignore the costs.
Totally. They often ignore the huge maintenance cost, the potential latency issues, the operational burden that all that complexity brings.
Can you give us a concrete example, something that makes the cost clear?
Sure. Let's say you're asked to design a pretty basic internal tool, like a job scheduling service. Maybe it needs to handle a few hundred tasks a day. Nothing crazy.
Okay.
The efficient, mature engineering choice probably use a simple, reliable message queue like Redis, maybe Kafka if they already have it, pair it with some worker instances. Simple does the job.
Makes sense.
But the candidate prone to over-engineering, they might immediately start designing, I don't know, their own custom distributed consensus protocol, maybe based on Paxos or Raft.
Wow.
Yeah, just to get this, like, perfect, absolute fault tolerance that the actual business requirements don't even call for.
And that's the difference between, say, a 2-week project that works reliably.
And a 6-month nightmare project that introduces a whole raft of new, incredibly hard-to-debug problems.
Because that custom system is brittle.
Precisely. It's hard to debug, hard to maintain, likely overkill for the scale needed. And companies end up paying a massive price for that kind of, frankly, ignorance of practicalities. The interviewer sees that tendency and immediately flags it. It screams, high maintenance debt, future pain.
So spending 20 minutes drawing this super complex microservice architecture when, really, a well-structured monolith would handle the required scale just fine. That's telling the interviewer you can't make real-world cost-benefit decisions.
That's exactly the signal you're sending. And there are other behavioral red flags, too. Things like narrow-mindedness, being unable to accept constructive feedback. You know, if you stubbornly argue for your initial idea, even after the interviewer points out a major flaw.
Digging your heels in.
Yeah. Or getting completely paralyzed by choices, showing you can't just make a reasonable assumption and move forward. It needs to feel like a collaboration, a pivot, based on feedback, not you rigidly defending your first draft.
Okay, this leads us perfectly into step 1 of the framework you mentioned. Understand the problem and establish the scope. And you start this section with a warning, right? An anecdote you call the Jimmy trap.
Ah, Jimmy. Yes. We all knew a Jimmy in school, right? This super smart student who always had their hand up first, rushing to answer every single question immediately.
Definitely. Speed equals smarts. That's what school teaches us.
Exactly. But in a system design interview, rushing, trying to give an immediate answer without deeply understanding the requirements, it gets you 0 bonus points. In fact, it's a massive instant red flag.
It's such a trap, though, because it plays right into that impulse to prove yourself quickly. Show them how smart you are.
I know. But system design just isn't a trivia contest. You get rewarded for being thorough, for being structured, not for speed.
So what's the mindset shift required here?
It's profound, really. You have to consciously slow down, resist that powerful urge to immediately jump into technical solutions like, oh, we should use this database.
Even though that's what engineers love to do, solve the tech puzzle.
Right. But tackling the wrong puzzle because you didn't understand the constraints, that's a guaranteed fail. In those first, say, 10 minutes, the most crucial skills are asking the right questions, making sensible assumptions, and just systematically gathering all the information you can.
And this is where the interviewer might test you on handling ambiguity, right? What if you ask a key question, like, what's the required latency? And they say, what do you think it should be?
That happens all the time. They want to see how you deal with that lack of definition. Can you make a reasonable judgment call?
So what should you do?
If they push back and ask you to make an assumption, the absolute key is to state it clearly and write it down. On the whiteboard, on the paper, wherever you're working.
Explicitly write it down.
Yes. You'd say something like, okay, the requirements mention low latency is important. So for now, I'm going to assume a target response time of under 100 milliseconds for feed retrieval. Let's write that down.
Why is writing it down so critical?
2 reasons. 1, it shows maturity and structure. You're documenting your baseline. 2, it gives you and the interviewer a concrete reference point you can both revisit later. If your design starts looking like it won't meet that 100 meters assumption, you can point to it and say, okay, based on this assumption, we might need to rethink this component.
Got it. Okay, let's give everyone listening a kind of checklist. What are the crucial clarifying questions they absolutely need to ask at the start to really nail down the requirements?
Yeah, a checklist is good. It basically covers 4 main pillars of scoping the problem. First, functional requirements.
Okay, functional, like what?
What specific features are we actually building? Is it just viewing content? Or does it need to include posting, commenting, maybe deleting? Get specific.
Makes sense. Pillar 2.
Scale and traffic. This is huge. How many users does the product have right now? Think daily active users, DAU, or monthly active users, MAU. What's the peak traffic load likely to be? And, critically important, what's the anticipated scale-up?
Anticipated scale.
Yes, you must ask. What scale should we design for in, say, 3 months, 6 months, 12 months? This forces you to think about growth, not just today's numbers.
So if they say 10 million DAU now, but expect 50 million in a year, that 50 million becomes a hard constraint for your architecture.
Actually, it changes everything. Okay, pillar 3, Non-functional requirements.
Non-functional, like performance.
Yeah, things like reliability targets, availability needs like 4 nines, 5 nines, acceptable latency, and data consistency requirements. Is eventual consistency okay, or do we need strong consistency?
Okay. And the fourth pillar.
Fourth, and this one's often missed but shows real-world thinking, existing infrastructure. Ask, what's the company's current tech stack? Are there existing services, platforms, or maybe databases that we should try to leverage?
Okay, wait. I want to push back on that a bit. Isn't relying on existing stuff sometimes a bad thing? Like, what if you inherit some ancient relational database for user data? Doesn't that just limit your design choices? Why is asking about it a positive signal?
That's a really excellent point. And yes, it absolutely can be a constraint, sometimes a frustrating one.
Right.
But asking the question shows you're thinking practically. A good senior engineer doesn't always want a blank slate. They know how to leverage existing investments, existing operational maturity. If the company already has, say, a huge, well-managed Kafka cluster running,
Okay.
then using that for message passing is probably way faster, cheaper, and safer in the short term than bringing in a brand new message queue technology they have no experience with, or worse, trying to build your own.
Ah, okay. So it shows you're thinking about organizational efficiency, speed to market, not just theoretical purity.
Exactly. You're demonstrating you think beyond just the tech to the business and operational reality. That's a very strong, positive signal.
That makes perfect sense. Okay, let's make this concrete. Run us through that newsfeed example you mentioned earlier. How would this scoping conversation actually play out? Let's get some hard numbers.
Great idea. So the interviewer starts with the broad prompt. Design a newsfeed system.
Okay, vague. Now we apply the checklist.
Right. Candidate asks, Pillar 1, features. Okay, what specific features are essential for V1? Interviewer might say. Let's focus on just 2 things. A user can make a post, and a user can see a feed of posts from people they follow or are friends with. No comments, no likes for now.
Got it. Simple features. What else?
Candidate asks about platform. Is this for mobile, web, or both? Interviewer. Let's assume both, but maybe prioritize the mobile experience slightly.
Okay.
Candidate asks about sorting. How should the feed be ordered? Strictly reverse chronological, or do we need a more complex ranking algorithm like, relevance? Interviewer. Good question. Let's start with reverse chronological for simplicity, but design it so we could potentially add a ranking service later on.
Smart. Build for the future. What about scale?
Candidate asks, Pillar 2. What kind of user limits are we talking about? Like maximum number of friends or followers per user? This really impacts data modeling. Interviewer. Let's cap it at 5,000 friends per user.
5,000, okay. And traffic?
Candidate asks, and what's the overall traffic volume? How many daily active users? Interviewer. Let's say we currently have 10 million DAU.
10 million DAU. Okay, that's significant.
And the candidate must follow up. What's the growth expectation? Interviewer. We anticipate growing to 50 million DAU within the next 12 months.
Wow. Okay. 10 million now, designed for 50 million soon. Big difference.
Huge. Finally, Pillar 4, maybe content type. What kind of content goes in the posts? Just text? Or are we talking images, videos? Interviewer.
Ah,
Good point. And he needs to support media files. Definitely images, ideally videos too.
look at that transformation. We went from design a newsfeed, totally terrifyingly open-ended, to a really specific constraint-driven problem. 10 ME in DAU, growing to 50 M, 5K friends max, mobile first, reverse chrono feed.
Right.
For now, must handle media. Now we actually have something concrete to design against.
Exactly. That 10 minutes of questioning is probably the highest leverage part of the entire interview.
Okay, scope defined, constraints understood. We're ready for step 2. Propose the high-level design and, crucially, get buy-in. And the key here is collaboration, right? Treating the interviewer like a teammate.
Absolutely critical. This isn't you just presenting a finished solution. It's like, here's my first draft, my initial blueprint, what do you think? You're seeking agreement before you invest a ton of time going deep on any one component.
And how do you present this blueprint?
Visually, get up to the whiteboard or use the virtual one. Draw box diagrams showing the main components and how data flows between them. The usual suspects. Clients, mobile web, maybe an API gateway, your web servers or application servers, load balancers.
Right, data stores, caches.
Dot caches, maybe a CDN if media is involved, possibly a message queue if things need to happen asynchronously. Just the big blocks first.
Okay, boxes are drawn, arrows show the flow. Before we dive into any of those boxes in detail, what's the essential sanity check we need to do?
The math check. Back of the envelope calculation.
Ah, yes, the quick math to see if this blueprint even has a chance of working at the scale we defined.
You absolutely have to. You need to verify if your proposed architecture can actually handle the load, the storage, the bandwidth implied by the constraints from step 1. Let's stick with our 10 million DAU number for the newsfeed.
Okay, 10 million DAU. So how do we translate that into something useful like requests per second? And you should do this out loud in the interview, right?
Definitely think out loud. Okay, so 10 million daily users. First, let's average that over a day. 10 million users divided by, what is it, 24 hours times 3,600 seconds per hour.
That's 86,400 seconds.
Yeah.
10,000, 86,400. It's roughly 115 requests per second if it were perfectly even.
Around that, yeah, about 115 QPS averaged out. But traffic is never perfectly even, right? You have peaks.
Right, peak load, lunchtime, evening.
So you need to estimate a peak to average ratio. Maybe it's 2x, maybe 3x, maybe more, depending on the service. Let's be conservative and say peak load is maybe 3 times the average.
Okay, so 150 QPS times 3, that's around 345 QPS during the peak hours.
Exactly, around 350 peak QPS. Now that's total QPS. We need to think about reads versus writes.
For a news feed, it's mostly reads, right? People scrolling.
Way more reads than writes. Let's assume a typical ratio, maybe 80-20. 80% reads, people fetching their feed, and 20% writes, people posting new content.
Okay, so 80% of 350 QPS is 280 QPS for reads,
Yeah.
and 20% is 70 QPS for writes.
Roughly.
Roughly, yeah.
And those numbers, 280 read QPS and 70 write QPS, are what you use to start sizing things. Can your proposed database handle 70 writes per second? Can your caching layer handle 280 reads per second with low latency?
If you chose a database that tops out at 50 QPS, your high-level design is already broken based on the math.
Precisely. Doing this quick check shows you're thinking about scale and performance right from the start. It avoids that classic mistake of designing something beautiful that works for 1,000 users but just completely falls over at 10 million. And you must talk through this with the interviewer. Does this peak ratio seem reasonable? Okay, based on this QPS, I think we'll need.
Got it. Talk through the math. What about use cases at this stage? How do they help solidify the high-level design?
Walking through the main use cases helps define the data flow more clearly. For our newsfeed, we identified 2 main flows earlier, right?
Yeah, feed publishing, writing a post, and newsfeed building, reading the feed.
Exactly. So you trace those flows through your boxes. Okay, for feed publishing, the user hits the API gateway, it goes to the post service, which writes to the database and maybe puts a message on a queue. Tracing it like that often helps you discover things you missed.
Like edge cases.
Yeah, or dependencies, like, oh, wait, when the user posts, how do we update their friends' feeds? That might naturally lead you to realize you need an asynchronous process, maybe involving that message queue, to handle the fan-out.
Okay. Now, a question about detail level here in step 2. Do we need to start defining specific API endpoints, like POST posts or sketching out database table schemas?
Good question. And the answer is, it depends entirely on the scope of the problem.
Context matters.
Always. If the problem is massive, like design the core Google search index, then no, spending time on specific API endpoints is probably way too low level. You should be talking about massive distributed file systems, indexing pipelines, crawler architecture.
Right, big picture stuff.
But if the problem is much smaller and more bounded, say, design the backend for a simple online multiplayer poker game, then yeah, defining the key API endpoints like game join or game deal might be perfectly appropriate and even necessary to show you understand the core interactions.
So how do you know?
You ask. Communicate with the interviewer. Would it be helpful if I sketched out the main API endpoints for the posting service now, or should we keep it higher level? Don't just dive into database schemas if they really want to discuss sharding strategies first. Let them guide the level of detail.
Always be communicating. Okay. So for our newsfeed example, we've got the high-level components, we've done the math check, and we understand the 2 main flows, publishing the feed data and retrieving the feed data. We've got buy-in on this general approach. All right, that brings us to step 3. The deep dive. This seems like where the real technical heavy lifting happens. The time allocation guide suggested this could be the longest part.
It often is, yeah, because this is where you demonstrate your depth on a specific critical part of the system. But before you plunge in, you need that explicit check-in.
The prerequisites check.
Exactly, just confirm. Okay, so we're aligned on the overall goals and scope. We agree on this high-level blueprint. Any major concerns with this direction before we dive into a specific component? Get that nod from the interviewer.
And then how do you choose where to dive deep? There could be several complex parts.
You have to prioritize. And ideally, you work with the interviewer to identify the most critical component, the one that's most challenging, given the constraints we established.
So you might ask them, where do you think the biggest challenges lie in this design? Which part would you like me to focus on?
That's a great way to do it. Or you can propose one. Based on the constraints, you can say, given the scale and the need for low read latency, I think the mechanism for getting posts to friends feeds efficiently, the fan out, is probably the trickiest part. Should we dive into that?
And the right deep dive topic depends heavily on the problem, right?
Totally. Like, if you're designing a URL shortener, the obvious deep dive is the hash function design, how you generate shortcodes, and critically, how you handle collisions.
Okay.
If you're designing a chat system, the deep dive is almost certainly going to be around handling millions of persistent connections, maybe WebSockets, managing online-offline presence status efficiently, and ensuring low message delivery latency.
Makes sense.
Hmm.
So for our newsfeed system, 10 MDAU, growing fast, 5K friends limit, need for reverse chronological feed, media files. What's the most critical, complex piece demanding the deep dive?
Given those constraints, especially the scale and the potential for 5,000 friends, it almost has to be the fan-out service.
The fan-out service. Why that specifically?
Because how you handle getting a new post distributed to potentially 5,000 friends feeds is the absolute core of the performance and scalability challenge here. It dictates latency for both the poster and the readers, and it drives a huge amount of system load.
And this is where we hit a major design choice, right? You mentioned fan-out on write versus fan-out on read earlier.
Exactly. This is the perfect place for a deep dive because it involves a fundamental architectural trade-off. This is where you show your ability to analyze trade-offs based on requirements.
Okay, let's unpack that trade-off. This is the kind of detail people need. Fan-out on write first. What is it, and what are we optimizing for?
Fan-out on write, sometimes called the push model. It means when Alice posts something, the system actively goes and writes or pushes a copy of that post, or at least a reference to it, into the inbox or feed cache for every single one of her 5,000 friends at the time she posts.
Okay, so the work happens up front during the write operation.
Right. The write load becomes very high. One post could trigger 5,000 write operations to various caches or databases. But the huge advantage is that when Bob, one of Alice's friends, comes to read his feed later,
It's already there.
it's already pre-computed, pre-assembled in his feed cache. Reading the feed becomes incredibly fast and simple. You're basically just retrieving a pre-calculated list, so you optimize for very fast read speeds.
Got it. Take the right hit for fast reads. Now, what about fan-out on read, the pull model?
Fan-out on read or pull is the opposite. When Alice posts, the system might only write that post to her own timeline or profile. That's it. Very low write load initially.
Okay, so how does Bob see it?
When Bob wants to read his feed, the system has to do all the work then. It has to go find all the people Bob follows, say up to 5,000, then query each of their timelines for recent posts, gather all those posts together, merge them, and then sort them, in our case, reverse chronologically.
Wow, that sounds expensive, especially at read time.
It can be incredibly expensive and complex, especially at scale. You have much lower write amplification, but the read operation becomes very heavy, involving potentially thousands of lookups and a complex merge sort operation every single time someone refreshes their feed. Read latency can suffer badly.
Okay, so back to our constraints. 10 million DAU, growing, need for relatively fast feed loads, implied by user experience, 5K friends max. Which model do we choose, and how do we justify it?
Given those constraints, particularly the scale and the desire for a good user experience, which usually means fast feed loads, we almost certainly have to choose fan-out on write.
Oh, and the justification.
The justification is that trying to perform that massive fan-out on read aggregation, pulling from up to 5,000 sources and sorting every time any of those 10 million users refreshes their feed would likely lead to unacceptable latency and put an enormous spiky load on the back-end data stores. Fan-out on write pushes the complexity to the background asynchronously, making the user-facing read operation much faster and more predictable.
Okay, so the fan-out service becomes this crucial piece that manages that asynchronous, potentially massive write operation when someone posts.
Exactly. And you'd likely introduce a message queue, like Kafka or RabbitMQ here. The initial post service just writes the post and drops a message onto the queue. Then, separate workers consume from that queue and handle the actual fan-out process of writing to all the friends' caches.
Why the queue? Why not have the post service do the fan-out directly?
Decoupling. Using a queue makes the system more resilient and improves latency for the poster. Alice gets her post-successful confirmation almost instantly. The queue handles the potentially long-running fan-out process in the background. If a fan-out worker fails, the message stays on the queue and can be retried. It prevents one user's post from blocking others if the fan-out takes time.
Ah, resilience and perceived performance for the writer.
Yeah.
That's brilliant. That's exactly the kind of justification an interviewer wants to hear, using standard patterns to solve specific problems based on constraints.
Right. And now, within this deep dive on fan-out on write, you can start detailing the other components involved in that flow.
Well-
And talk about the post service itself, what does it do, maybe stores the canonical post data. Then, critically, how do we find Alice's 5,000 friends efficiently? This is where a graph database, GraphDB, often comes in.
Why a GraphDB? Why not just a relational database with a friendships table?
You could use relational, but querying, give me all friends of Alice, when Alice has 5,000 friends, and potentially millions of users in the system, can become slow in a traditional SQL database. Graph databases like Neo4j or AWS Neptune are specifically optimized for traversing these kinds of relationships very quickly. Finding those 5,000 friend IDs is exactly what the fan-out service needs to do fast.
So specialized tool for a specialized job.
Mm.
Okay. Post service, GraphDB finds friends, message queue holds the task. Fan-out workers pick it up. Where do they write the feed data to?
To the newsfeed cache. Since we chose fan-out on write, the goal is pre-computing the feed. So the fan-out workers write the post ID, or maybe the full post data, depending on the design, into a cache keyed by each friend's user ID. This cache is typically something very fast, like Redis or Memcache.
So when Bob requests his feed, the application just queries Redis for feed.bopusread and gets back a list of post IDs, already sorted perhaps.
Exactly. Maybe it gets a list of the latest 100 post IDs. Super fast, likely sub-millisecond reads from the cache. That's the payoff for the fan-out on write complexity.
Okay, this deep dive is getting really specific now. But you mentioned a trap earlier, the time sync trap. How do we avoid getting lost in the weeds here?
Right. Time management is crucial. You've shown you can design the core mechanism, the fan-out. What you need to avoid is getting dragged into minute details that, while interesting, don't further demonstrate your ability to handle the core scalability challenge.
Give us that concrete example again in the newsfeed context. What's a time sync?
Spending 15 minutes detailing the intricacies of, say, Facebook's historical EdgeRank algorithm, or trying to whiteboard the exact machine learning pipeline Twitter might use for feed ranking.
Why is that bad? It shows knowledge.
It shows academic knowledge, maybe. But it burns precious minutes without proving you can design the infrastructure to handle 10 million users reliably. The interviewer cares more about: how would you shard the newsfeed cache? How do you handle cache misses? How does the load balancer distribute requests to the feed service? Focus on the scalable system, not just algorithms disconnected from implementation at scale.
Got it. Stick to the components and interactions that address the core constraints: load, latency, data volume. Show you can connect the post service, queue, GraphDB, fan-out workers, and cache into a coherent, scalable system.
That's where you provide the strongest signals of architectural thinking, using the right tools like the GraphDB for relationships and the cache for fast reads, and explaining why.
Okay, we've gone through the scope, the high-level blueprint, the math check, and we've deep dived into the critical fan-out service. Now we hit step 4, the wrap-up. You said this is vital for the final impression.
Absolutely vital. It's your last chance to really shine and show critical thinking beyond just the initial design. Don't just trail off when you finish drawing.
What's the #1 rule for the wrap-up?
Never, ever claim your design is perfect or finished. Don't say, and there you have it, a perfect newsfeed system. That signals inflexibility, maybe even arrogance.
So instead,
This is your prime opportunity to proactively discuss potential bottlenecks, limitations of your design, and areas for future improvement. It shows you're thinking critically about the real-world operation of the system.
okay. And if the discussion explored a few different options along the way, like maybe you briefly considered fan-out on read.
Then yeah, a quick recap can be helpful. Just briefly remind the interviewer. So, just to summarize, we decided on the fan-out on write approach primarily to optimize for read latency, given the scale, even though it adds complexity to the write path via the fan-out service and queue. Refreshes their memory, reinforces your reasoning.
Makes sense. And beyond bottlenecks and recap, what other follow-up points show that deeper operational thinking?
You really want to touch on things that show you understand what it takes to actually run this thing in production. Interviewers love seeing this broader perspective.
Okay, give us the checklist for that final wrap-up discussion.
Sure. First, error cases and failure modes. How does the system handle things going wrong? What happens if a server running the fan-out service crashes? What if the network connection to the database blips? Briefly mention resilience patterns, like the message queue ensuring posts aren't lost.
Okay, error handling. What's second?
Operational issues. How would you monitor this system? What are the key metrics you'd track? Latency of feed loads, queue depth, cache hit rate. Maybe briefly mention logging and alerting. You could also touch on deployment strategy. How would you roll out changes safely? Blue-green deployment, canaries.
Shows you're thinking about keeping it running smoothly. And third, you mentioned this earlier, looking ahead.
Yes, handling the next scale curve. We designed for 10 million, maybe aiming for 50 million. Proactively ask or state, what happens when we hit 100 million DAU or a billion?
And what kind of points would you raise there?
This is where you identify future bottlenecks based on the next order of magnitude. Our current GraphDB setup works for 5K friends, but at 100M users, the sheer number of edges might require sharding the graph, or maybe introducing dedicated relationship caches. Or the single newsfeed cache cluster might become a bottleneck. We'd need to think about federated or heavily sharded caching. It shows you're anticipating future challenges.
That's really strong. Thinking beyond the immediate problem. Anything else for the wrap-up?
Just briefly proposing future refinements or next steps, show you have ideas you'd tackle if you had more time. Given more time, I'd look into adding basic content filtering, or we could investigate optimizing the feed serialization format for mobile clients to save bandwidth. It leaves the impression that you're already thinking about V2. Tag a critical do's and don'ts, a summary checklist. Okay, maybe it's useful to just boil all this down into a super clear do's and don'ts checklist for people.
Yeah, perfect. Let's hit the do's first, the positive signals you absolutely want to send.
Okay, the do's. Number 1, always ask for clarification. Never assume anything. And write down the key requirements and assumptions you make.
Crucial.
Understand the context. Is this a tiny startup needing something fast, or a huge company needing massive scale and reliability? Tailor your solution.
Right. Don't propose Google's architecture for a 3-person startup.
Exactly. Communicate your thought process constantly. Think out loud, especially during those back-of-the-envelope calculations or when weighing trade-offs.
Let the interviewer hear your brain working.
Suggest multiple approaches if relevant, especially early on. Then clearly justify why you're choosing one path over another based on the requirements.
Shows you considered alternatives.
Treat the interviewer like a teammate. Bounce ideas off them. Ask for feedback. Does this approach make sense? Am I heading in the right direction here?
Collaboration, not confrontation.
Once you have the high-level blueprint agreed upon, focus the deep dive on the most critical, most challenging components first. The bottlenecks, the scalability linchpins.
Prioritize impact.
And finally, just never give up. Even if you get stuck, keep thinking, keep suggesting ideas, show resilience.
Okay, those are the do's. Now the flip side, the don'ts. The red flags we need to actively avoid. Remembering Jimmy.
The don'ts. Don't walk in unprepared. Have a basic understanding of common system design patterns and problem categories, like designing feeds, chat systems, URL shorteners, search, etc.
Do your homework.
Don't jump straight into a solution. Resist that urge. Clarify requirements and scope first, always.
Slow down to speed up.
Don't get bogged down in excessive detail on one minor component too early. Get the high-level design agreed upon before optimizing one small part. Avoid that time sink trap.
Breadth first, then depth.
If you're genuinely stuck on something, don't just sit there in silence forever. It's okay to ask for a hint. I'm a bit stuck on how to best handle X. Do you have any suggestions?
Yeah.
Show self-awareness.
Better than freezing.
Definitely don't think in silence for long periods. A few seconds to gather thoughts is fine, but extended silence is painful for the interviewer and tells them nothing. Narrate your thinking.
Keep the dialogue flowing.
And lastly, don't assume the interview is over just because you've drawn the last box. Remember, step 4. Ask for feedback throughout, and always discuss bottlenecks and improvements at the end. #tag practical time allocation guide. Now, fitting all of this into a, say, 45-minute or 60-minute interview requires some mental time boxing. It's flexible, of course, but having a rough guide helps.
Yeah, how should you mentally allocate that time across the 4 steps?
Okay, for a typical 45-minute session, roughly, step 1, understand scope. Aim for about 3 to 10 minutes. Don't rush this. Getting the requirements right is key.
Solid foundation.
Step 2, high-level buy-in. Maybe 10 to 15 minutes. This includes drawing the boxes, explaining the flow, and doing that crucial back-of-the-envelope math check.
Get the blueprint agreed.
Step 3, deep dive. This is usually the biggest chunk, maybe 10 to 25 minutes. Really focus your technical depth here on the most critical component you agreed on.
Where you show your tech chops.
Step 4, wrap up. Allocate a specific 3 to 5 minutes at the end for discussing bottlenecks, improvements, error handling, and future scale. Don't let time run out before this.
That final impression. It seems like that structure really forces you to hit all the key signals the interviewer is looking for. It turns ambiguity into a process.
That's the whole idea. The system design interview feels less like this terrifying black box and more like a structured conversation. It's less about having the single right answer and way more about demonstrating that iterative, collaborative thinking process, how you handle ambiguity, how you make trade-offs under pressure.
So the framework is like the map.
Yeah, the framework is your map, but your willingness to ask questions, to collaborate, to think critically, that's the compass that actually guides you through it effectively.
This has been incredibly helpful, really breaking down how to approach what feels like such a daunting interview. But before we wrap up completely, let's leave our listeners with that final provocative thought, something to chew on that connects back to our newsfeed example.
Okay, so we established early on that a key requirement for our newsfeed was supporting media files, images, and videos, not just text.
Right. That came out in the scoping phase.
Now think about this. In that final wrap-up phase, step 4, imagine the interviewer throws you a curveball. They say, actually, our biggest business priority right now has shifted. We need to drastically minimize bandwidth costs for delivering those images and videos above all else.
Okay, cost optimization becomes priority 1.
How does that specific constraint potentially shift where you should have focused your deep dive? Instead of the fan-out service, what other component suddenly becomes the most critical bottleneck to discuss and optimize, and why? What new technologies or architectural patterns does that constraint force you to bring into the conversation immediately?
So if bandwidth cost for media is suddenly the top priority, the deep dive probably shouldn't have been just on the fan-out logic for post IDs. It probably should have been on the entire media storage and delivery pipeline. You'd immediately have to talk about using object storage like S3 instead of trying to stuff blobs in a database. You'd need to discuss content delivery networks, CDNs, for caching media closer to users globally. Maybe pre-signed URLs for secure direct access.
Precisely. The focus shifts entirely from optimizing back-end database cache writes and reads for the feed structure to optimizing global content distribution, caching strategies for large binary files, and minimizing data transfer costs. It's a completely different set of technical challenges and trade-offs.
It really highlights how a single change in requirements or constraints can ripple through the entire design and dictate where the real complexity lies.
The design process is never truly finished. It just refocuses based on the most pressing constraints, whether they're scale, latency, cost, or features.
Fantastic. A great reminder that the conversation is ongoing. Well, that's all the time we have for this deep dive. We really hope this 4-step framework helps you turn that feeling of being overwhelmed by system design interviews into a feeling of having a structured, actionable plan.